let's take a look at this binomial distribution problem. So we read the problem first. A research shows that more students are taking transfer level math courses compared to remedial math courses. The record shows that 45% of the Forest Hill College students already completed a transfer level stats course. So this one, the probability is 45%. Suppose 9 students are selected randomly and let X be the number of students who completed a transfer level statistics course. Answer the following questions. So this is a binomial problem. How do you know? So the probability, P equals to 0.45. This is called, we call this a success rate because 45% they completed a transfer level course. They took a stats course. So in a college, either you took that course or you never took that course. Either you have it or you don't. So binomial works like a coin, right? Either one side or the other side. So imagine that you are holding a coin on your hand, either one side or the other side. So that is a binomial, either one or the other. So either you have the course in your transcript or you don't have this course. So the success rate is 0.45, and then they select 9 students randomly, so the sample size is 9. So for a binomial distribution, the binomial formula is n choose x. We have n choose x times the probability of success, so which is p, and then raised to the x power, and then 1 minus p raised to n minus x power. So the first notation that is called n choose x. This is a combination. It is not a fraction. P is success, 1 minus P is failure. So 45% students, they have it, they took the course. So that means 55% of them, they didn't take that course. So either you have it or you don't. All right, so we have n, we have p, and then what is x? X, you have 9 students, right? So what is the smallest x? Smallest x is 0. So as you can see that on the table, 0. So that means out of 9 students, none of them took a stats course. So x can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The maximum is 9 because you pick 9 students randomly. It is possible that all of them took the stats course. So x can be from 0 to 9, and x is a discrete random variable because x has 10 distinct outcomes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 distinct outcomes. So the binomial formula, so let's say we have 0 success. How do we write the binomial formula? So we have this one, I have to switch to a darker color. So we have a 9 choose 0, and then 0.45 success rate raised to a 0 power, not x raised to a 0 power, and then 1 minus 0.45 raised to 9 minus 0 power, and then 1 success, then that will be 9 choose 1, 0.45 to the first, and then 1 minus 0.45 raised to 9 minus 1. You can write 0.55 in the second parenthesis, but I don't recommend you to do so. I always write 1 minus the probability of success, that equals to probability of failure. And then we can keep going. 9 choose 2, 9 choose 3. Let's do the writing first, and then we do the computation. 9 choose 5, 9 choose 6, 9 choose 7, and then 9 choose 8, and then 9 choose 9. This is a 0.45, so they are all 0.45. 0.45. I make the table so long is because I want to push everybody to write this down over and over again. So by the time you finish this problem, the formula is in your mind. So when you do this on a test or on a homework in anywhere, you don't have to go back to your notes and check out the formulas. 2, 3, 4, 5, 6, 7, 8, 9, and then the next factor, 1 minus success, and then this is a 9 minus 2. And then I'm going to write this first. 1 minus 0.45, 1 minus 0.45, 1 minus 0.45. You don't need to calculate this by hand. I will show you how to get the answer using one calculator command. And then 1 minus 0.45, 1 minus 0.45, and then 9 minus 3, 9 minus 4, 9 minus 5, 9 minus 6, 9 minus 7, 9 minus 8, 9 minus 9. If you are taking a class, you see a problem in your class, they might not give you this table. So based on my experience teaching a stats class, if you don't provide such table, people are not able to answer any probability questions. We need to write everything out, get all the probability, summarize them on a table, and then we use the probability to answer questions. All right. And then the next one is a calculator command. How do we go to that calculator command? We need a command called binomial PDF. So let me show you how to get there. You have to press second, and then you have to press the vars key, and then you have to select binomial PDF. There is a CDF. How come we don't use a CDF? CDF is you are adding up multiple probabilities at a time. I don't recommend you to use the CDF. I recommend people use the PDF. When you add probability, we do that manually. I really don't recommend using CDF. So I'm going to use binomial PDF to get probabilities one at a time. So let me go back to the command. So this one is binomial, BIMOM. Oops, the PDF, and then here is the command. So the command is you have to input the sample size. So I'm going to call that an N, and then the success rate, and the number of success, NPX. So we have 9, the success rate is 45, and then the number of success is 1. So we can save sometimes right here. So the only thing that you have to change, oh, this is a 0 success. So this is a 1, then the next one is a 1 success, 2 success, 3, 4, 5, 6, 7, 8, 9. So the only numbers is changing is the last number. So again, the first one is the sample size, and then you don't really have to call that a sample size. You can call that a number of trials. So we take 9 students, right? We try this 9 times. So the trials is 9. So here is the calculator part. You go to second vars, you press second, you press vars, and then you have to find binomial PDF, so which is option A in my calculator. So binomial PDF, if you are using a newer calculator, they might bring you to a manual, all right? If you are using a newer calculator. So for the binomial PDF, if you are using a newer TI-84 plus CE or C, they will bring you to a manual. You will see 3 things, okay? They will still ask you MP and X. So let me tell you what you see in there, because I am looking at my TI-84 plus at this time. So if you are using that newer calculator, they will ask you 3 things: trials, which is N, and then P, which is the probability of success, and then XX is the number of success. Now out of 9 students, none of them took a stats course, or 1 of them, 2 of them, 3 of them took a stats course out of 9 people in your trial. So, and then using the older calculator, you do have to separate them using a comma, 0.45, and then 0 success. You press enter, there you go, you get your first probability. For probability, I usually use 4 decimal places. So this is a 0.0046. And then I know you don't, let's practice this again, and then I will teach you a shortcut. Second vars, binomial PDF, 9 trials, success rate is 45%, and then 1 success, close parenthesis, then you get your second probability. And then, so for the next one, you don't want to keep going back to second vars and then binomial PDF, right? I understand we are lazy, right? So using technology, we can be lazy. So if you want to save some time, simply press second enter, so the previous command pops up, and then you move your cursor. Yours is different than mine. So if you are using a TI-84, move the cursor. So the cursor is on 1. So now the 1 is flashing, right? If you type 2, the 2 will override the 1. So in mine, I have to put the cursor on the left-hand side of 1. So once I type 2, it will override the 1 for me. And then that is my next probability. And then second vars, and then override the 2. And then I have 0.2119, and then second enter, second enter, not second March, second enter, and then you override the 4, 0.2600, and then second enter, we override the 4, and then that will be 0.2128. Second enter, override the 5, we have 1160. And then second enter again, we override the 6, we have 0.0407. And then second enter, we override the 8, 0.0083, and then second enter, we override the 8 to 9, and then this one we have 0.008. In your calculator, you might have this. They might show you, so let me move this away. They might show you a scientific notation. So in your calculator, when you do the last one, do you see a e negative 4 at the end? So you have a something like 7.57 and then a bunch of numbers. On the right hand side, you see a e and then negative 4, right? This is a scientific notation. That means 7.57 times 10 to the negative 4, which is the same thing as you move the decimal point 4 steps to the left. So you get 0.000757, and then I keep 4 significant digits. I add 1 to the 7. That's how I got the 8 at the end. All right. So using this table, we are going to use these probabilities to answer a bunch of questions. So before we get into that, I know you are very busy in writing everything down and then checking your answer. So you can take a screenshot, because we are not going to keep going back to this table. So take a screenshot right now, and then we will use these probabilities to answer the rest of the question. All right, do it. Okay, you done? All right, let's look at the probability problems. So in part B, I would like to calculate the expected value, variance, and standard deviation. So for binomial distribution, there is a specific set of formula to calculate these three things. So B, expected value for binomial only is n times p. So we have 9 students, and then the success rate is 45%, so that equals to 4.05. And then variance, again, for binomial distribution only, x stands for the number of success, x is a random variable, is n times p times q. Q is the failure rate. So 9 times 0.45, failure rate is 1 minus success, because it's either a success or a failure, right? Where is that? 0.45. So this one gives you 2.2275, and then standard deviation, it doesn't matter what distribution you are doing, is always the square root of variance, which is the square root of 2.2275, so you get around 1.49. All right, what is the 4.05 mean? 4.05 means if you keep taking 9 in that college, you walk around in the college, you keep taking 9 students out randomly, okay? Every time you grab 9 students out, in the long run, I expect to see 4 of them completed the stats course, okay? In the long run, I expect to see 4 out of 9 people completed the stats course. And then this 1.4, if you round this up to a 2, it is easier to explain this way if you round this up to a 2. So in the long run, I expect to have 4 people completed the course. If you want your estimation to be flexible, you plus or minus 2. So 4 minus 2 is 2, 4 plus 2 is 6. So that means if you keep taking 9 students out randomly, I expect to see 2 to 6 of them completed the course. So in this way, your answer is more flexible. So that's how you interpret these numbers. And then in part C, you take 9 students, at least 5. So what is at least 5? At least 5 is, so at least 5 is x, greater than or equal to 5, right? So in this problem, we can include 5, 6, 7, 8, and 9. So that means you go ahead, you add up those probabilities. So that is 0.2128 plus 0.1160. Just look at the probability table. Every x corresponds to a probability. The table we just did is called the probability distribution of the random variable x. Alright, so you get the sum is your answer. Okay, let's switch color for the rest. So for part D, what do we have? Part D is asking at most 4. So at most 4 is probability x less than or equal to 4. That includes 4, 3, 2, 1, 0, the sum of 5 probabilities. So that is 0.2600, 2119, 1110, 0339, and then the last one is 0.0046. So the sum is the answer that you are looking for. And then part E is you are looking for the probability that all of them. So what is all mean? You grab 9 students out, right? All of them means all 9 of them. So that is the last probability. So all 9 of them, that is equals to 0.0008. And then F is none. None means 0. So probability x equals to 0. So that is the very first probability we got on the table, 0.0046. And then the last one is you pick 9 people. Can you have 15 of them completed the course? Okay, just like this. You take 4 classes. Can you get 8 letter grades at the end of a semester or a quarter? That is impossible, right? So for the last one, you have 9 trials. You are looking for 15 successes. That is completely ridiculous. So the probability is equals to 0, 45%, 15, and then 1 minus 0.45, you have 9 minus 15, that is equals to 0. 0 means this is not possible. You took 9 classes in a school. Can you get 15 letter grades? No, that is not going to happen, right? So let's verify this using a calculator. We go to second VARS binomial PDF. We have a 9, success rate is 45, and then you are looking for 15 success, you are going to get a 0. So that means this is not going to happen. All right, so that will be all in for this problem. So once again, if you are taking someone else's class and you don't have the table I set up for you, make a table for yourself. So the probability question, they are so much easier if you have the probability table written right in front of you. Otherwise, this is going to be a disaster, okay, based on my experience. All right, I see you all in the next video.